Hello everyone, I hope you all are fine. So let's start our today's topic. In our today's session, I have brought the process of leaching that were left to discuss in the previous lecture, so that we will discuss in detail. Okay, so leaching, as I have written, or the chemical separation. So you have to understand specifically this method is useful when all the other methods are not applicable of concentration of metallic ore, like hydraulic washing. If we are not able to apply, if we are not able to apply magnetic separation, or we are not able to apply the froth flotation, so in that case the process of leaching is to be done. Actually this process is very simple, but here we have to use a suitable chemical that will act as a solvent. In this method, ore is dissolved in the suitable solvent. We have to pick a specific chemical that will act as a solvent, and we have to dissolve that metal to concentrate them, and then after that it is to be recovered. Okay, but the main basic principle that comes in front of us, the impurities are less soluble. When you will dissolve in a specific chemical, then you will observe that metallic ore will dissolve but impurities will not dissolve. So where the metal will go, that will move in a filtrate. Here I am telling to you what is the filtrate. Suppose you are filtering that. This is a funnel, and if you will filter, then impurities will settle here because these are not soluble, and the metallic ore will come with the solvent or the chemical which we have used to dissolve this metallic ore. The ore will come with this solvent, so that we call it, this is a filtrate. Okay, this we call it filtrate, and impurities that will remain in the sieve you can say, or the filtering material. Okay, and impurities will not dissolve. Now the bauxite ore contain SiO2, iron oxide and titanium oxide in the form of impurities, as are concentrated by this method. So we use the method of leaching to concentrate them. So now you see here I have written there Al2O3.x moles of water. So this is the specifically to be known as bauxite ore, and the leaching of bauxite ore is to be done, that we must know, in the process of concentration. So here we have to use sodium hydroxide as a chemical, and when we dissolve in this, then we get a complex that is to be known as NaAlO2, sodium meta-aluminate, or simply you can call it sodium aluminate. After that it is to be filtration, then you will get it sodium aluminate, then water is to be added, then you will get it NaOH and AlOH whole thrice, and again this is to be filtered, because here it is a PPT and it is in a aqueous form. So that PPT we will get it, and after that this aluminium hydroxide is to be heated, so that will convert into Al2O3 and 3 moles of water comes out. So here we are doing the recovery of metal oxide. So finally Al2O3 bauxite ore is converted into metal oxide. Okay, so here we have used here the specific chemical. This is of NaOH. Here I want to remind you one thing. In the process of leaching, the chemical whatever you are using to dissolve a metallic ore, to concentrate them, first of all it will make a complex, so that you can say this is of NaAlO2. So first of all it will form a complex, and after that it will get dissociate, and that will convert into a recovery of metallic ore is to be done to convert into a pure aluminium. So the remembering point is to be there. In the process of leaching, the chemical whatever we are using, it will form a complex. It helps in the formation of complex. Okay, and where the metallic ore is to be moved, it will move with the suitable solvent. Impurities will not dissolve. Okay, so here I have brought the leaching of gold and silver to understand, which you have, that is very important. In the metallurgy of silver and the gold, the respective metal is to be leached out, because these are the noble metal, they don't have large impurities with them. So most probably what is the process is to be done? Leaching procedure is to be done. Here we have to use a dilute solution of NaCN, sodium cyanide, or potassium cyanide in the presence of air from which metal is obtained by the process of displacement. That question is very important and already has come in the board exam. Okay, so when first of all you have to pick a noble metal like gold and silver, then after that you have to put a chemical like NaCN or dilute solution of NaCN and KCN, and after that the displacement reaction is to be done with the help of more reactive metal like zinc. Zinc will act as a reducing agent, you can say also, and that will help in the reduction also. Okay, so you see here, suppose you are, I have mentioned in the chemical reaction that will help you to understand the process or this leaching process of gold and silver. M represents the gold and silver, either Ag or Au. Cyanide ion I have picked from the NaCN or KCN. Okay, so I have taken its only negative part. Then because we are using a dilute solution, so we have to put some water and supply of oxygen is to be done. Then I have told always the leaching reagent. Leaching reagent means the chemical which we are using to do this process, that will form a complex. So it is forming a complex here. First MCN whole twice. Here M represents the metal, either it may be of gold or the silver, that is in a aqueous form. Aqueous, why? As I have told, metal will dissolve with that solvent and OH ion comes out. And after that what will happen? We have to use a more reactive metal. So zinc is more reactive than gold and silver. Then I have taken here the zinc. So zinc is it will show the displacement, then metal will displace, zinc will form a complex with this Z and Cn whole twice 2 negative, and 2M gold or silver in the form of PPT will separate. Here reminding once again, M represents the either the Ag or the Au, that you have got it. Let's complete this process with the one example. Suppose you are taking Ag, balancing you can do, number of balancing you can do yourself, plus Cn negative, same you can write 4Ag plus Cn negative plus 2H2O plus O2, then what you will get it 4Ag Cn whole twice 1 negative, that is in a aqueous form, that complex dissolves. Okay, then you have 4OH negative. Now in the next step what is to be done, that I have written. Okay, now in the next step you have to use 2AgCN whole twice 1 negative, then zinc you have used here, then that you will get it ZnCN. Zinc starts to form the complex with it, and 2Ag comes out in the form of PPT. So the same procedure is to be done with the gold also. 4Au plus 8Cn 2H2O plus O2, that you will get it 4Au Cn whole twice negative, but aqueous you have to write. Okay, then 4OH will come out, and after that you are having 2Au Cn whole twice, this complex that is to be react with the more reactive metal, this is zinc, and then what will do, zinc ZnCN whole twice 2 negative plus 2Au comes out. Then we have got a free gold and the free silver. So this is the recovery of gold and silver is to be done with the help of the process of leaching. I think you all have got it, but here I am reminding you, this reaction is to be known as this, when we are using a more reactive metal zinc to displace this less reactive metal, either the gold or the silver. So this reaction is to be known as displacement reaction. Okay, zinc is helping to displace gold or silver here. Okay, and the complex is forming here, so that complex will form with the help of leaching reagent. And here what are the leaching reagent? That is of KCN or NaCN, and their dilute solution we are using as a chemical. Okay, so and if you will see here the one more thing, Here the metal oxidation state, if you will find out, +1 is to be there, but here zinc is to be 0, and that is going to be, if you will find out, because Cn is -1. So if you will solve this, then you will get it +2 oxidation state. Okay, in that case, so zinc is going to be oxidized. So here it is helping in the process of reduction, because metal is acquiring a +1 oxidation state, and here it is going to be 0. So that question can be asked during the board exam based on that concept. Here zinc helping to displace a less reactive metal, so the displacement reaction is taking place, but it helps in the process of reduction also, because itself it is oxidizing and it is reducing a less reactive metal in a free form. And the suitable chemical which we are using, these are leaching agent, these are dilute solution of KCN and NaCN. I think you all have got it. That's all for today.